This question involves 3D shapes, and it's mentioned the word volume, so we're going to have to work with some formulas. So we look at the shape that we've been given, and we can see that it's made up of a cylinder and half a sphere. So the first thing we should be doing for question A then is we should be writing down that the volume of a sphere is 4/3 pi r cubed, and the volume of a cylinder is pi r squared h. Now they give us the volume of the sphere on the front of the exam paper, but the volume of the cylinder they don't, so we must remember about the cylinder. It's a prism, so it's the cross-section area, which is pi r squared, times the length of the prism, which was h, so that's why it becomes pi r squared h. Now because we're working with a hemisphere, we have to remember that the volume of the hemisphere is going to be 4/3 pi r cubed divided by 2, so just got to be careful with that. So those are the two formulas. They both require a radius, so we go back to the picture and decide what the radius is. So the radius is 3 in both cases, so we can just write r is 3 meters, and this formula requires a height, so we go back to the picture again, and the height of the cylinder is 30 meters, so 30 meters. And quite often with these formula questions it's a case of then once you've identified the correct numbers, you then put them into the formulas. So the total volume is equal to the volume of the hemisphere plus the volume of the cylinder, so that's going to be 4/3 times pi times 3 cubed divided by 2 plus the volume of the cylinder, which was pi times the radius 3 squared times the vertical height of 30. So we've put our numbers into the formulas, and then it's really a case of using our calculator carefully. So 4/3, so 4/3 with the fraction button, times by pi times by 3 cubed equals, divide by 2, that's the volume of the hemisphere. And again, with all exam questions it's useful to write down some intermediate answers so that we can check we're going to get the method marks if we make a silly mistake at the end. So 56.55 for that bit. Can leave the whole thing in the calculator there so we don't get any rounding errors at the end. And then we're adding on and bracket, because we want all of this sum to be done, to be added on to the previous one, so we put a bracket, then we do the sum. So pi times 3 squared times 30, close the bracket, equals, so 900, and so the whole thing came to 904.78. Then we read the question carefully, and it wanted the answer to 3 significant figures. So because it wanted the answer to 3 significant figures, then it'll become 905, and this is 3 dimensions, it's 3D volume, so our answers will be cubic, not centimeters of course, because we were dealing with meters, so cubic meters is the units. So that's how we could do 3D volume, as long as we remember to write down formulas and put in the correct values as we need to. So when we go to the next part of the question, then we can see that it wants us to work with the volume of a sphere. So we've got to calculate the radius of that sphere. So because of that, the first thing we're going to write down is the formula for the volume of a sphere, which is given at the front of the exam paper, but it's better that you remember it. Now the question says it wants the radius. So in other words, we want the r to be the subject. So we need to rearrange this. So the volume times 3, because we're going to take the divide 3 across by timesing. So we're going to times by 3 first, and that gives us 4 pi r cubed. We then want to, and we know that V is 500 cubic meters, because that was given to us in the information of the question. So we now want to get r on its own, so 4 pi needs to move, and that 4 pi is timesing by r cubed, so to move it we do the inverse of divide. So we end up with 3v over 4 pi, so divide by 4 pi is equal to r cubed, and then we recognise the opposite of cubing is cube rooting. So r is equal to the cubed root of 3v over 4 pi. So that's the subject made of R, so that we can find its value, and we've rearranged appropriately. So we can now put in our numbers. So R is equal to the cube root of 3 times 500, because it told us the volume was 500, and we divide that by 4 pi. So we get our calculator, and second function cubed root. So most calculators nowadays have a cubed root key, so second function cubed root. So put that back into normal mode. Second function cubed root. Open a bracket because I need all of this sum to be done before I do the cube rooting. So bidmas, do brackets first, so get the bracket in there. So 3 times 500 divide by, open another bracket because I want 4 times pi to happen, and that's the division bit, and then close the bracket for the cube root, equals. So the answer is 4.92. So R equals 4.92 centimetres. No, it's metres because we're dealing with metres. So 4.92 metres. So we think that's going to be the answer. And at this stage, you should know by now what I'm going to say, guys. We should check. And if we think that is the answer, then when we calculate the volume using the formula for the sphere of 4/3 pi r cubed, then when we do 4/3 times pi times 4.92 cubed, then the answer should be just about 500, because that's what the question said the volume was. So 4 fraction button 3, so 4/3 times pi times 4.92 cubed equals. So the answer came to 498.9, which is close enough to 500 because we rounded it. So we can be pretty sure that the check worked. Okay. So again, it's as always. Get an answer, you've got an answer for a reason, check it works in what the original formulas were, and then you should be okay. So that's an example of working out volume in 3D using formulas, and then to get missing values, then working through the idea that we can rearrange the formulas to make the missing letter the subject, then put the numbers in and get the answer, and then do the final check